The way we always start out physics is by talking about graphs, and the reason we do that is because graphs is something that's going to stick with us all year long. It's a really important part of studying physics. So in this video we're going to look at some specific graphs, but first you should realize that graphs are everywhere. If you open a newspaper, open an online site, graphs are used to represent relationships throughout all kinds of industries. Some of you guys who are into the stock market look at graphs every day. If you take an SAT or an ACT, they always use graphs. So you're going to keep running into them. There's a graph that we keep seeing a lot lately. So why are graphs such a big deal? The reason is because graphs are what help us find a relationship between two variables. It's a visual representation of a physical relationship. So you can actually see that relationship instead of just looking at an equation. Sometimes it's an easier way for us to interpret things and to make predictions. So in this video, we're going to talk about the different kind of graphs that you'll see in physics. You see a lot of different graphs in math. For first year physics, you're not going to see all of those. So we're going to go over the main types and the equations that go with them. So one thing that's super important in physics is that when we look at slope, y-intercept, or the area under the curve, all of those things have a physical meaning. So we're talking about physics here. One thing you'll find is that the math that we do is not really that difficult in first year physics. It's applying those physical meanings to the graphs and equations that you're comfortable with. That's the part that can be a little bit challenging. So when we talk about graphing, you always have to talk about variables. And I know you've heard this every year in science, but I always have kids who get them mixed up still. So I keep pointing them out. So the independent variable, that's the one that the experimenter is manipulating. So the one that the experimenter chooses the interval for. So like if you take a data point once every second, then time is your independent variable. If you see how far something went, or like how long it took to go a few seconds, then you could make distance your independent variable. So it depends on how you set up an experiment, which variable is independent and which is dependent. So independent is chosen by the experimenter. Dependent changes depending on what you do to the independent. A really easy way to remember that, you may have seen this before, I think some other classes use this idea, is dry mix. So dependent responsive equals y-axis. So the y-axis is the thing that responds to the independent variable. So manipulated means controlled. The manipulated variable is the independent and goes on the x-axis. So when we graph data, we always put the independent variable on the x-axis. In physics, regardless of whether time is dependent or independent, we always put it on the x-axis as well. So you'll find that graphs are kind of always done the same way. I know that this particular thing is a little bit of a pet peeve for our environmental science teacher because sometimes she does graphs the other way, but in physics, time always on the x-axis. All right, so we're going to go through the different types of graphs that you're going to see. The first one is the easiest. You'll see a linear graph, and you should all know the equation is y equals mx plus b, and that those two variables are directly proportional to each other. Okay, now this one is also linear, same name, but there's no relationship between x and y because it doesn't matter what happens to x, y is still the same value. So if I look at that with my y equals mx plus b equation and I put in 0 for x, then this whole term becomes 0, so y equals b. So when we talk about these, you need to know the names, you need to know the equations, okay, and you need to know the relationships. And I'll talk about one more thing when we get to it here. So this one, now we're getting to curves. Our other three graph shapes are going to be curves. So this graph shape is called a hyperbola in physics. This is another one that you may have a different name for in math. So in this, y is inversely proportional to x, not indirectly. Indirectly would imply that it's linear with a negative slope. So this is an inverse proportion here between x and y. And then you see the equation y equals m over x plus b. So this is the first one that's a curve, and it's something that we're going to do something special with any of the curves. We do something in physics called linearizing graphs or linearizing data. So what we do is we look at that shape, we assume what equation might be represented by that shape, and then we graph the variables that are different from y equals mx plus b. I'll explain that as we go. So we're going to do that with that hyperbola. So what happens is if we graph new variables and we alter them correctly, we're going to get a straight line. The reason we do this, the purpose for linearizing graphs, is to confirm that our assumption about the original graph shape was correct and to see that we have the correct equation for that relationship. Okay, so if I go back to my hyperbola that I had before, we said that was y equals m over x. Okay, and we're going to leave off the plus b, all right? So if we have y equals m over x, if I graph that 1 over x versus the y, if it's truly a hyperbola, if that equation was correct, I'm going to end up with a straight line here. So that's confirmation that my equation was correct. If I graph these two variables, and I get a different shape, then that may show that there's more to the relationship than what I originally assumed. Okay, so if I write the equation for this line, I can follow that y equals mx plus b format, but because x is 1 over x here, this is the equation for that hyperbola that we assumed before. So this graph and the previous graph both actually have the same equation. The difference is you're actually graphing different data. Okay, so that shows that the hyperbola was correct if you get a linear graph out of that. Okay, so the next graph type, this is out of 5, so this is 4 out of 5. This is a parabola. In physics, we call this a top opening parabola because if we had the other half of it over here, it would kind of make a bowl. So it opens to the top. So a top opening parabola, the equation for it is y equals mx squared plus b. So again, if I want to linearize this, again, I do that to confirm that my assumption about this equation was correct. Because what if there was something else with it? Maybe there was another x cubed term or a y squared term. You can have other equations that make a very similar shape. So that's why we confirm it by linearizing the graph. So I'm graphing y versus x squared. If it is a top opening parabola, I always square the x to linearize it. So that's something else you guys need to know about graphs. You need to know the name of the shape. You need to know the relationship, the equation, and what you would do to linearize it, all of those things. Okay, so the equation for both of these graphs would be y equals mx squared plus b. Okay, they're just graphing different things. One's y versus x, one's y versus x squared, so it looks different, but you're actually graphing the same relationship there. Okay, number 5, this is actually the last one, side opening parabola. So again, they call it side opening because if you had the entire parabola like that, then it would open to the side. So in this one, y is proportional to the square, or x is proportional to the square of y. So I always say to myself, if it's on its side, I square the y. Those sounds kind of go together. It helps me remember it. So here, I'm going to square the y value. And if I do that, if I had the entire equation correct, if this was the true equation for this data, then that would give me a linear graph when I graph the two. Writing the equation would give me the exact same equation for either one of those. Okay, so what we're talking about in this whole section is that it is important to understand graphs, regardless of whether you're going to be in physics and go on and study physics forever. Most of you won't, but you will all see graphs your entire life. It's really important to be able to read them, interpret them, and make decisions based on them is what we end up doing when we see graphs on the news and things like that. Specific to this class then, you need to know those 5 great basic graph shapes. You need to know the name, the equation, and how to linearize each. So those are the 5 graph types that you'll see in this class. So you'll see more as if you take more physics later on in high school or in college. So that's all we're going to look at in this particular section.